vocabulary words. White blood cells will commute through the blood, but their job is not in the blood. They'll move through the blood, and that's kind of like their subway channel, but they will, their actual job will be in the tissues. So what they're going to do is they're going to kind of roam around looking for dead cells or foreign materials by a process called chemotaxis. And so basically they're just attracted to the dead cells of the foreign materials so that they can grab them and remove them. So there are 5 types of white blood cells. 3 of them are in a group called granulocytes. 2 of them are in a group called agranulocytes. So the difference between granulocyte and agranulocyte: granulocytes have substance-filled vesicles that easily stain, so when you're actually staining them to make them into a slide. Agranulocytes have tiny vessels that don't easily stain, so you wouldn't be able to see them very easily on a blood-stained slide under a microscope. So the 3 types of granulocytes are neutrophils, basophils, and eosinophils. And then the remaining 2 types of white blood cells that ring up the following 5 are granulocytes, lymphocytes, and monocytes. Okay, so let's talk about all 5 of these. White blood cell types: 1 is a neutrophil. It's a granulocyte, and it's the most common of all the white blood cells. It has a multi-lobed nucleus, and it has small but not very dense granules. So they're tiny granules, and they're not very spread out. The neutrophils will be the first responders to infection. That's one reason they're the most common white blood cell. They're attracted to evagers by chemotaxis, and they're capable of a process called phagocytosis, which literally means cell eating. So they're basically going to eat foreign cells. Each neutrophil is large enough to eat 10 bacteria before dying. Once the white blood cells have performed this function and eaten the invaders, they will die at the site of infection and will form a pus. Basophil is the rarest granulocyte. It has a 2-lobed nucleus and large granules that stain blue. They increase in number during allergic reaction and release something called a histamine, which promotes inflammation, and also release heparin, which prevents blood clots. Which doesn't sound like a good thing, but when you're having an allergic reaction, you don't want to have a blood clot because your blood has to be able to get to that area to fix the problem. So you want to basically hold off the blood clotting long enough to fix the issue, and then go about healing after the first aid has been applied of healing the allergic reaction. Eosinophils is the 3rd type, and it's also granulocyte. It's uncommon, but there are more of them than basophils. Their appearance: they have a 2-lobed nucleus, and their granules stain red. They increase in number during allergic action and decrease inflammation. They also increase in parasitic infection. Oh, I'm sorry, I got these 2 backwards. I got a bit distracted, I'm sorry. So these ones are in allergic reaction and decrease inflammation, whereas the previous ones promote inflammation. So if you were thinking, Miss Wood, you're confused, I was. So sorry about that. So sorry I got this backwards. Okay, the 4th type of white blood cell is the first type of a granulocyte. It is the 2nd most common white blood cell. Its appearance is that it's slightly larger than the red blood cells, but it's the smallest of the white blood cells. So it has a nucleus, and it has very little space for cytoplasm. So the majority of the entire cell structure is a nucleus. It produces antibodies, so because of that, we're not going to spend much time talking about them. We're going to focus on them next module. Okay, the 5th type of white blood cell, monocytes, the 2nd type of a granulocyte. It is the largest of the white blood cells. It is actually quite uncommon. It has a kidney bean-shaped nucleus, and it actually has more cytoplasm than the other agranulocyte, which were the lymphocytes. They destroy foreign materials by phagocytosis, and they can actually take in even more than the neutrophils could, which was the 1st type of white blood cell. The neutrophils could only take in 10 bacteria. These can take in 100 bacteria before dying. Okay, so how are all these formed elements made? It's a process of hemopoiesis, which is formed in the red bone marrow. Blood is also a connective tissue because it contains cells, and that's the first reason that it's a connective tissue. The 2nd reason is because it has a connective extracellular matrix, which is the plasma, and the 3rd reason that it's considered a connective tissue is because it has protein fibers. The protein fibers are not very obvious or easily apparent. That's because they only become obvious when the blood actually clots. So it's a process called hemostasis. So when an place is injured, there are 3 stages to hemostasis to occur to heal the injury. The first is vasoconstriction, the second is a platelet plug, and the third is coagulation. We're going to talk about all 3 of these. Okay, so the vasoconstriction stage is first. So this basically means that the blood vessels will constrict. So when a blood vessel ruptures, a reflex that will naturally occur is that the broken ends of the smooth muscle will surround the vessel and contract, so basically close the tear. The more the damage to a particular area, the more vasoconstriction will occur. The second is the platelet plug stage. So the blood platelets will swell and get sticky, and they'll start to stick to each other and the blood vessel walls. This will basically cause them to cause a pileup and form in one area, and that will plug the damaged area so the bleeding will start to stop. This occurs in the damaged area because the blood will be exposed to collagen. So your blood inside your circulatory system, there's no collagen in there. So only when your blood vessel breaks and the blood is actually exposed to the tissues outside of the blood vessels will it be exposed to collagen. And in that mix, when the collagen mixes with the platelets, it's going to form this structure that allows the clotting to actually occur. So that's when the fibers will come into play. So once the platelets begin clotting, they're going to release a chemical called thromboxane, which stimulates other platelets to stick. So basically it's going to be a positive feedback system. So when platelets form, clotting occurs, causing more clotting to occur, causing more clotting to occur. Obviously, it's going to have to get to a point where that clotting stops, otherwise all of our blood would clot and we would die. So we'll end up having to get to a point where that process ends in a little bit. But the third step is coagulation. So there are 3 steps to coagulation. This simple process is shown in your book where there's basically a flow of events. So the first thing is that the tissue or blood vessel damaged produces prothrombase. Prothrombinase is an enzyme, so typically when something ends in ase, that is indicative of it being an enzyme, and it's an enzyme that activates prothrombin. So the prothrombinase will be produced, and then the second step, that enzyme will convert prothrombin into thrombin. And then the thrombin is actually another enzyme. It can miss the memo that it's supposed to end in ACE, but it's an enzyme too. So the thrombin will be a second enzyme, and it will convert the fibrogen into fibrin. So this is basically going to activate the fibers in your blood to cause the clot. Okay, so the blood clot's just going to look like a net, which traps the blood and keeps it all back. There's a figure of that in your book. I think it's 11.7. I should have typed that out. But there are actually many more steps to starting this process, and it all begins with coagulation factors, which is another one of your vocabulary words. This occurs in the liver, and figure 11.8 is very thorough to show the process by which all the coagulation factors take place. When ending coagulation, because obviously we need to end it at some point, otherwise all of our body will coagulate. The body will produce anticoagulants, which will prevent certain blood factors from being activated. So certain blood factors that you can see in figure 11.8 will stop being activated, which will stop the process. Okay, blood types. So there are 4 main blood types, A, B, and O. We talked a little bit about this when we did the blood type lab last week. So the surface of red blood cells, that should be red blood cells, so it should be C, not another S. So the surface of red blood cells has something called an antigen. The antigen is what actually determines our blood type. So type A will have A antigens, type B will have B antigens, type C will have C antigens. Our bodies will produce antibodies opposite of the antigens that we have. So figure 11.9 kind of illustrates this, but let's... Okay, so we would have, let me see if I can add a page here. Okay, I don't think it's going to let me add a page right here, so let me do this instead. So type A will form, well, let me do it this way. Sorry, let's do this. Antigen, antibody. So I'm going to type on right on top of this. So Type A blood will form A antigens, so it'll form antibodies of the opposite type, which would be type B. Type B blood will form type B antigens, which means it'll type A antibodies. Type AB will produce A and B antigens, which means it'll produce no antibodies. Type O will produce no antigens, so it'll produce type A and B antibodies. So, sorry it's kind of overlaid on top of the PowerPoint here, but we talked about that in class a little bit last week as well, just to review a little bit. Okay, so blood types are determined by our genetics. So, based on what your parents have determines what you have. So, your blood type, so A and B are, sorry, I thought I turned my pen off. There we go. A and B are dominant to O. So you can possibly have A O blood or B O blood, but O is recessive to A and B. So this person would be type A, this person would be type B. A and B are codominant to each other, which is why you have AB blood. So your book goes through some Punnett square examples based on a parent reproducing and what offspring they'd have. So back to biology, genetics, right? So if we have a parent who has type B and another parent who has AO, oops, sorry, right, AO, whoop, okay, that's AO. What we can do is build what we call Punnett square, and we write one parent across the top and another parent across the side, and then we just fill in the boxes. Okay, so if all four of these boxes represent the possible children they can have, 50% will have type AB blood, 50% will have type BO blood. So that's just the basics of how it works. We learned that in biology, so this is just a really quick review. We can talk about this more in class when we're actually together, and I have a whiteboard to work on if we need additional time on the topic. Okay. Blood types. So our blood also has something called the Rh antigen, or what we call the Rh factor. This is actually in addition to and independent of the ABO blood types. So this is what gives us the positive and negative blood type, right? So A positive, O negative, right? Those things. It comes from the Rh factor. So if you have Rh positive blood, you have the Rh antigen. If you have Rh negative, you don't have the Rh antigen. So that means that someone who makes the Rh antigen produces no Rh antibodies. And if they lack the Rh antigen, they produce the Rh antibodies. I'm sorry, yeah, that's right, antibodies. Okay. One other thing to note about the genetics-wise of this is positive is dominant to negative. So if you have your blood type, you have some that are positive and some are negative, the positive will dominate over the negative, so you'll have negative blood type. So the only way you can have a negative blood type, or so you'll have a positive blood type. The only way you can actually have a negative blood type is if both alleles are recessive, or that negative, and then you would have negative blood type. So this would be one allele, this would be the other allele. So both negative. Okay. With all this in mind, type O negative is considered the universal donor because they don't produce any antigens. They don't produce A or B antigens or Rh antigens. Whereas type AB positive would be considered the universal blood recipient because they don't produce any antibodies. Okay, so we're going to end it there for this lecture. We're going to continue this more in class and continue this module. So have a great week. Enjoy your fall snow day.